All right, so Andrew, this showed up on a calculus exam, right? Multiple choice. You got a test on Friday.
Yeah.
What do you think the answer is?
Does not exist.
Okay, I got an E, non-existent.
Yeah.
Nashka, what about you?
I think it's B.
Think it's 2? B? All right, cool. Cool. Remy, what about you? I got some B's, okay? Got 2 B's. That's good. That's good. Hazel, what about you?
I think it's B, but I also think it's like a trick question. It's gonna be something weird.
Why do you think it's a trick question? This is a real AP multiple choice problem.
Because it seems too easy.
Seems too easy. You think it's B?
Maybe.
Andrew, Mr. Baker remembers this problem for a couple reasons. Just so you know, don't feel too bad, right?
Okay.
We got together as math teachers in the county. You know, like all the calculus teachers get together, and one of the teachers, I'm not going to say where they're from, brought this up, and they asked, "How in the world do you do this problem?" You know.
Yeah.
So other calculus teachers in the county weren't really brushed up on how to solve this problem.
Right.
You know what I'm saying? I got some news for you. It's not B, and it's not E. So here we go, Andrew. You ready? Let's talk about some non-traditional limits with operations. Okay? We got to be really good at drawing graphs today. Here we go, Andrew. Let's draw this first one.
It's okay.
All right, got f of x and g of x graphs right there. All right. Andrew, in case you were wondering in the back of your mind, did Mr. Baker know how to solve this?
Yeah.
Just want to let you know, I didn't want you to doubt Mr. Baker's abilities. Okay.
Yeah.
Cool. All right, so Andrew, got those graphs? Almost. Nashka's still copying them down. Almost there. Jack, you got them down already? Cool. Emily has the foot. It's great. Getting better. Well, let's do some examples here. What is the limit as we approach -1 of f of x plus g of x? Well, here we go. Carter, as I approach -1 on f, what's the answer? As I approach -1 from the left and the right on f?
It does not exist.
Okay, you're like D and E. Right? And then you're like, g of x, come over here, and you're like, okay, as I approach -1 from the left and the right,
Does not exist.
does not exist. So you're thinking, does not exist, right?
Mm-hmm.
You think that's the answer, Carter?
No.
It's not. And you're like, what? Everything that you've taught us is not making sense. Andrew, have we done problems like this before?
Yes.
Yes, we actually have. Like, we've done problems like this before. They were on your first quiz. You know, it's like you guys got like 1 plus D and E, and you were like, oh, it's D and E, right? And Mr. Baker had a big old umbrella over you. You just didn't know it. I was keeping you out of the storm. All of your answers were correct. Like, nothing about them were wrong. But now today, because we have more knowledge about limits, I'm asking you to pump the brakes. Okay? If you are doing operations with functions, adding, subtracting, multiplying, if you're doing operations with functions and limits, right? And you think the answer is D and E, pump the brakes, Carter. Okay? What are you talking about, Mr. Baker? Well, let's just look at it a different approach. What happens if we approach -1 from the left of this exact same expression? So Carter, you ready?
Right.
What do you get when I approach -1 from the left?
-1.
You get -1. What do I get when I approach -1 from the left?
-2.
You get -2. Answer is -3. All right. What happens if we want to do the limit as we approach -1 from the right? Carter, what do you get when you approach -1 from the right on F?
-2.
You get -2. What do you get when you approach -1 from the right on G?
-1.
Uh-oh, Carter. Did the limits from the left and the right equal each other?
They do.
So is the answer D and E? What does it actually equal?
-3.
If the limits from the left and the right equal each other, the limit exists. The answer to this one is actually -3. Andrew, what do you think?
It's not too bad.
It's not too bad?
Yeah.
Emily, what do you think? You having a good day, Emily?
I'm having a great day.
Do I need to like rough somebody up for you? That's on camera too, so. Okay, if you just give me a name, all right, just let them know. All right, Andrew, let's do one more of those with this graph, right? Let's do the same thing. All right, this one's gonna be a little different. All right, so a little different limit notation there. All right. Carter, what do you think, man? We're approaching 1 from the left and the right of F, right?
Yeah.
What do you get when you approach 1 from the left and the right on F?
2.
You get 2. So you're like, Ms. Baker, this is 2. What does your gut tell you? What does your gut tell you when you see this x plus 1, Carter? Are you really approaching 1, or are you really now approaching 2? So what do you get when you approach 2 from the left and the right on G?
Does not exist.
Ooh, you got D and E. Hey, Carter. You think the answer is D and E?
It is not.
We don't know yet,
Or
right?
could be, but
We don't know yet. Could be.
I don't think so.
But like Carter, are we doing operations?
We are.
Are we adding 2 functions together in this example? You know what I'm saying? We could be adding, subtracting, multiplying, whatever. If you're doing operations and you get D and E right off the bat, pump the brakes, check the left and the right. Okay, check the left and the right. So if I did the left first of this exact same expression, okay? So Carter, what happens if I approach 1 from the left on F?
You get -2.
You get 2, right? You get 2. What happens if I approach 1 from the left on G? Or not 1. What are we approaching?
2.
2 from the left. So what do I get when I approach 2 from the left?
2.
2, right? So 2 plus 2 is 4. Okay, pretty good. What about when I approach 1 from the right of this exact same expression?
You get 2.
So 2, 1 from the right on F is 2. What about 2 from the right on G?
3.
3. Hey, guess what, Carter? What's the answer?
It does not exist.
It does not exist, right? We can erase that question mark and say, you know what, Mr. Baker? It doesn't exist. Why? Because the limits from the left and the right didn't equal each other. You cool with that?
Yeah.
Interesting. Does any of this information help us out with number 1 yet? No. Okay, does not help us out just yet. All right? Can I erase that? You feel good about it? All right. Let's talk about another one of these things. this is technically example 3, I guess, huh? All right, so Andrew, let's do 2 more graphs. We'll call this F. Okay, good. Not G of X. I'll let you copy that down. And whenever you give me the thumbs up, we'll start. I got a thumbs up. Okay. All right, let's have some fun with this one. Andrew, you ready?
Oh, yeah.
Don't worry, Jack. I'm not going to forget about you. Okay? Andrew, this one's a little different. This is not adding, subtracting, or multiplying or something like that. Not operations. This is actually a function inside of a function. Composite limits, composition of limits. Right?
Yeah.
What does your gut tell you on this one?
What do you want?
Close.
Okay.
Do you want to find the limit as you approach one of?
X.
You said plug in 1, right?
Yeah.
Where would you plug 1 into?
G of X.
Because that's on the inside.
Yeah.
So with this one, you actually do the limit of the inside,
Okay.
right?
Yeah.
What is the limit as you approach 1 of G? Well, as I approach 1 of G from the left and the right, what do you get?
Zero.
You get 0, right? So what do you think this actually turns into?
F of the limit of 0.
Or just f of 0,
F of 0.
right? You
Yeah.
get f of 0. What is f of 0?
2.
2. Hey, life is good. Life is good. Jack, you ready? Jack, you always get the fun ones. So Jack, you're welcome. This is where it gets interesting. Because Jack is an interesting person. Jack, you and this problem are one, okay? All right, so Jack, what do you think?
Probably plugging 0 to F of X.
Are we plugging in 0?
Yeah.
No, we're not, Jack. We're doing limits. So Jack, do the limit as you approach 0 of the inside. What is the limit as I approach 0 from the inside?
2.
It's 2, right? So you would then think, well, Mr. Baker, this is just f of 2. What's f of 2?
Does not exist.
Carter.
Yes.
You think that's a D and E?
Maybe. Probably not.
It's not D and E. Okay? Even with composition of functions, right? Even with when you have a function inside of a function, pump the brakes today. Pump the brakes. Okay, Jack?
Okay.
Pump the brakes. With the composition, right? With the composition of functions, folks, it is all about the approach. Okay? It is all about the approach. So Jack, what does that mean? Well, when we went to do the limit on the inside, right? We came over here to F and we were like, Mr. Baker, I'm approaching 0 from the left and the right, and we got 2. But my question is, Jack, how are we approaching 2? Are we approaching 2 from both sides, right? Are we approaching 2 from below?
You could probably say that.
I mean, right?
Yeah.
I mean, are we approaching 2 from the left and right from below? Think about that. Aren't these values, Andrew, getting like 1.5, 1.6, 1.7, 1.8, 1.9, 1.99999? Like, see how they're like from both sides, we're getting closer and closer to 2? If you were going to think about that on a number line, I just told you we were going from 1.5 to 1.6 to 1.7 to 1.8 to 1.9. How are we actually approaching 2? From the,
The left.
it's all about the approach with composition of limits. When I do this limit on the inside, Andrew, okay?
Yeah.
When we approached 0 from the left and the right, we were approaching 2 from below. But when you think about it on a number line, when I approach 2 from numbers below 2, you're actually approaching 2 from what? So you know what this actually turns into? That inside function gives you another limit because it's all about the approach. So Jack, what's the limit as we approach 2 from the left on F?
0.
It's actually 0. So the answer to this thing, Carter, is what? Carter.
0.
It's 0, right? It's 0. The answer to that whole limit right there, that composition of limit expression, is 0. Mr. Baker, you didn't do that on example number 3. Well, Carter, when I approached 1 on G, were we approaching 1 from above and below?
Yes.
That cancels it out. You know, like one's below, one's above,
Yeah.
those cancel out, right? You don't have to worry about that. But on some other ones, when both are from below, what happens if you're coming from above? It's actually coming from the right now. This would be like a little plus sign right here when it comes from above.
So if it's from below, it's negative, it's from the top, it's positive.
Yep. So, what's the answer to that AP multiple choice question over there? You have all the information you need right now. What do you think? Andrew, which one is this? Is this a composition of functions or a operations? Are we like adding, subtracting, multiplying? Or are we like taking a function and plugging it inside of a function?
I think we're adding subtraction.
This is not adding,
Okay,
subtracting.
got it. So we're plugging a function into it. Yeah.
Yeah. I mean, you could just call this function right here G. You know what I'm saying?
Right.
You are literally taking G and plugging it into F. This is the composition of functions. What did I just tell you about composition functions? It's all about the what? It's all about the approach. You got that, Andrew?
Yeah.
Okay. Operations, pump the brakes and check the left and the right. Compositions, it's all about the approach. So here's what I'm getting at. Folks, if you can't look at this right now and be like, Mr. Baker, that vertex is 0, 1, and it opens down. If that takes you longer than 2 seconds, we got to get there. We got to get there. Okay? We got to get there. Andrew, that is a parabola with a vertex of, now, that's just Mr. Baker going back to fun days like this. Andrew, you remember what that is?
Yes.
What is it?
That's vertex form.
Yeah. And don't I basically just have this right here as my parabola?
Yeah.
So I could look at that and be like, ooh, H is 0, K is 1, 0, 1, and why does it open down?
Negative.
It's negative, right? You should be able to draw that graph. So Carter, with all that being said right there, you know what I mean? We're approaching 0 from the inside. When we start to approach 0, what are we actually approaching?
1.
From
The left.
the left, because right, we're coming from 1 from below, so this whole expression actually turns into, what is the limit as we approach 1 from the left? Well, what is the limit as you approach 1 from the left?
3.
I don't think anybody out there said C. Or maybe they weren't brave enough. But the answer is actually C. because you understand those weird, quirky, non-traditional limits. Molly, what do you think? Kind of scary? You can say it.
Like, a little confusing.
It is a little confusing. Like Mr. Baker's gonna give you time today to like stare at it. Like you need to stare at it for a minute. You're gonna have some questions. But Carter, if you just remember the basics, what are you supposed to think about with operations?
The approach.
Nope. Check the left and the right. Right?
Yeah.
When you have functions inside of functions, it's all about the approach. It's all about the approach.
Okay.
You got that?
Got it.
Ready? You cool?
Yep.
All right.